So today we're going to be learning how to create an equation for a parallel line. Now, parallel lines at this level, we're looking at lines that have the same slope but different y-intercepts. This comes from the idea that if we have two lines with two different y-intercepts, let's say I have a point here and a point here. Parallel lines meaning that they have the same slope, they're never going to touch. But now, if I were to move my y-intercept onto the same spot as the other one, now the rate of motion that it's crossing the axes is going to be the same, so those two lines are touching at every point. And now, if we had a third variable, those lines would be perfectly fine. They're two lines that are the same thing, but they're on top of each other. But at this level, parallel lines typically have the same slope, but different y-intercepts. So let's just assume they have to be different. So that's exactly what we're going to do. We're going to look at an equation, look at a point, and we're going to create a line that goes through that point, but is parallel to this. So that means we're going to need to create an equation in what we call point-slope form. Point-slope form is going to be the equation of y minus a y1 equals m times x minus an x1. And this tells us our three pieces of information that we're going to need. We're going to need to find a y-coordinate, an x-coordinate, and a slope, all of which is given to us in this information right here. So we're going to look and we're going to say, hey, I see that we have an x, I see that we have a y, actually we're going to call that x1 and y1. And then looking at this equation, I know this is in the form of y equals mx plus b, which means the number in front of the x is going to be our slope. And we can just plug that information in. So we can take the y1, which was our 8, our x1, which was our 2, and the slope, which was 3. And we can solve this equation just like that. Now, this is really only two steps. We need to distribute, which means we're going to multiply by that 3. Y minus 8 is 3x minus 6. And the last thing we're going to do is we're going to get rid of the constant over here to isolate our y variable. That's going to give us y equals 3x. 8 minus 6 is going to give us a 2. And we've created a new equation in slope-intercept form, y equals 3x plus 2. So we want to take an equation in point-slope form, plug in the information, and just solve for y, and that's all we're doing. So let's try another one like that. Let's take our equation of y minus y1 equals mx minus x1. And we're going to take all the information we see right here, our y1, our x1, and in this case, our slope is negative. So our y1 is a negative 7, our slope is a negative 15, and our x1 is a positive 13. And what you might notice is that we have a double negative right here. And those two negatives, when we have two negatives adjacent to each other, that's going to turn into a positive sign. So it's actually y plus 7. And then we're going to deal with the rest as we normally would. We're going to distribute that negative 15, which is going to be a negative 15x, negative 15 and negative 13. Let's see. 15 times 10 is going to be 150. 15 times 3 is 45. 150 and 45 is going to give us 195. Cool. And the last step is just to isolate the y by getting rid of that constant over there. It's going to cancel out, and we have y equals negative 15x plus 188. Boom. There we go. Easy enough. And so one of the questions you might ask is, well, does a fraction change how we're going to work it? And we always want to be careful with fractions because sometimes we may need to clear them. But for the most part, this one's going to work itself right out. So I have my y1, my m, and my x1. I have my x1, my y1, and my slope. So let's plug in this information and see what happens. So 16, negative 4, and 1/2. And so some of our eagle-eyeds might notice the fact that we have plus a positive right here because I have two adjacent negative signs, which means that's really x plus 4. And here we go. Now, typically we'd like to clear this fraction, but in this case we notice that 4 can be taken in half. So 1/2 of 4 is going to be, well, half of 4 is 2. One of those is just 2. Half x plus 2. We notice that the half x doesn't change anything because we're just going to leave it as that 1/2 of x. The last thing we're going to do is get rid of that 16. So y is equal to 1/2 x plus 18. Here we go. So we see the fact that even with a fraction, it works out pretty well. So let's go ahead and let's try something with a slightly bigger fraction. How about 3/4? So y minus x minus. So you might say, okay, well, this is going to change a little bit about how we approach it. And for the most part, you are correct. We're not going to approach this 100% the same way, but the approach is pretty much the same thing. We're going to take our y1, our x1, and our slope, which is 3/4. Again, notice that we have two adjacent negative signs, which turns that into a plus 24. And we're going to distribute this 3/4. Now we recognize the fact that 3/4 of x, nothing crazy happens. We just leave it as 3/4 x. But this 3/4 of 24, we're going to break this into two parts. I'm breaking the 24 into fourths and then taking 3 of them. So let's actually look at this as two different pieces. Because a fraction, if I have 3/4 times 24, I'm saying, okay, take a fourth of 24 and then multiply whatever your answer is times 3. Actually, I should put that in parentheses so we don't think it's an x. So I'm going to take a fourth of 24. So if I break 24 into fours, I get 6 of them. And I'm going to multiply that times 3, which is going to give me 18. So 3/4 of 24 is 18. The last step that we do is we're going to add the 16 over here to isolate our y variable. And so we get y equals 3/4 x plus 34. There we go. Now the last one, I'll leave these both on screen. On the last one, what I want you to do is this is a decimal. There's two ways to solve this. You can either try and convert this fraction to, or a decimal to a fraction and solve it that way, or you can see if you can't just work it with a decimal. So go ahead, pause the video, give a shot on number 9, unpause it when you're done, and see how well you did. It'll work both ways on screen. Okay, so let's see how well we did. So I have my equation of y minus y1 equals m times x minus x1. And I'm going to plug in my information of what I see directly in front of me. My y1 is a negative 15, my x1 is a 10, my slope is a negative 0.2. Now, if you did convert this to a fraction, what you'd notice is that the 2 is in what we call the tenths spot. So that's negative 2/10 or negative 1/5. If you did it this way, we're going to end up getting the same equivalent answer, but you're going to have your answer in fractions. So yours would look like y minus. You'd still have the negative 15 here, and you'd have a 10, but instead of having the negative 2/10, you'd have negative 1/5 because they're equivalent. Okay? In both cases, our first step would be to distribute. We have to distribute that decimal or that fraction to the inside terms. Oh, and let's not forget, we have adjacent negative signs. So if I have minus a negative, it's going to end up being plus a positive. Same here and same there. So y plus 15, y plus 15. So nothing changes right there. It's going to be negative 0.2x. And what we're going to see right here is we're taking 0.2 times 10. So I know that I'm just going to multiply the numbers. 2 times 10 is 20, and I'm going to add a decimal. So 20 with a decimal is just the number 2. Perfect. Over here, I'm going to do something very similar. I'm going to take negative 1/5 x, and I'm going to have to break that 10 into fifths. So if I break the 10 into fifths, that's 2. So negative 1 and negative gives me a positive 2. So in either case, I end up with the same constant on the outside. The only difference is what the slope looks like. And so our final step is we subtract the 15 on both of these things, which cancels out the 15 on the left, which isolates our y, equals negative 0.2x. 2 minus 15 is going to give me a negative 13. Y equals negative 1/5 x, and the same thing over here. 2 minus 15 is going to give me a negative 13. And so we see the fact that these answers are equivalent, even though one is a fraction, one is a decimal. And there we go. Okay, so today we're figuring out if two lines are parallel or not, and if they're not, we have to state why. So really what it comes down to is let's set up both these equations in slope-intercept form so we can figure out what their slope is. Now, the first one, what we can tell is it's already in slope-intercept form, or y equals mx plus b. And what we notice is that the m is 2, so I now have a slope of 2. And I want to figure out what the slope of the second line is. So I'm going to take that second line, 2x plus y equals 8, and I'm going to rewrite it in slope-intercept form, which means for this one, all I need to do is move that 2x over. So I'm going to go ahead and add my 2x. I'm going to go ahead and add my 2x to both sides. So that's going to cancel out over there. And I'll have a y equals 2x plus 8. And now I can compare the two slopes. So I know that the two slopes are the same. So I know that they are parallel. And I know that they both have different y-intercepts, which means they're not the same line. These are two unique lines that are parallel. So they're parallel. For some reason, I wrote parallel with a T. Let's ignore that. And they're two separate lines. So parallel and two separate lines. Awesome. So let's do the same thing to the next one. It's as simple as just looking at it and saying, hey, this is already in slope-intercept form, so I'm looking for, will this have a slope of 3 or not? So the first thing I'm going to do is I'm going to move that x over. So I'm going to add 6x to both sides, which cancels that out. And I'm going to rewrite this right here. So 2y is 6x plus 10. And the last thing I'm going to do is I'm going to divide everything by 2, which isolates my y. So I get a y is equal to 3x plus 5. And so this, like the first one, they both have the same slope, so I know that they are parallel, this time with a t again. I don't know why I'm doing parallel like that. But I notice that we have a y-intercept of 5 and a y-intercept of 5, which means that if I look at this line and I say, hey, here's my x and y graph, and I have a 3x plus 5, it looks something like this. My next line has the same slope and the same y-intercept. So I'm looking at the same line. So parallel, and they are the same line. I'm not really sure what's going on in my writing today. I seem to want to blend letters together. So likewise, these are going to end up with your two different results of if they have the same slopes, two different lines mean they're separate. Two of the same y-intercepts means they're the same thing. The line by comparison that we had up here, we had one with an intercept of 6, and this one moved at the same rate, but it was a little higher up on the graph. So assuming that these were drawn perfectly, two parallel lines that never touch, two parallel lines that are right smack dab on top of each other. So what I want you to do is I want you to pause the video, try number 5, unpause it when you're done and see how you did. Okay, so let's see how we did. I had a slope of 1/2, and I want to compare that to what my next one's going to be. So I'm going to add my x. It's going to cancel that out. And I have a 2y is equal to x plus 14. Then I'm going to divide by 2, which leaves me with a y equals 1/2 x plus 7. And I'm going to compare my slopes. Oop, I know these are parallel. Parallel written correctly this time. But again, I have intercepts of 7, so I know that these are, just like before, they're going to be crossing through the same point. So parallel, and they're the same line. You could also call them overlapping, but I think overlapping sometimes gets confused with. People think that overlapping should be like this, but oftentimes people say, well, hey, if I have a line like this and a line like this, aren't they overlapping at that point? And technically, yes, they are, but we know that that's not what we want. Overlapping technically means that, but whatever. So let's go ahead and let's try one a little bit more complex. Now, the only difference here is that neither one of these is in slope-intercept form, which means that first what we're going to have to do is we're going to have to solve for the slope on this one. So negative 4x plus 2y is 6. I'm going to write that first one over here, and I'm going to write the second one over here. Negative 6x plus 3y is 30. I'm going to solve both of them separately. So add 4x, cancels that out. So 2y is 4x plus 6. Then I divide by 2. So we get y is 2x plus 3. So I'm looking for a slope of 2 on this one, and I want to see if we get anything remotely close to that. So I'm going to add my 6x. Cancels that out. I have 3y is 6x plus 30. Divide by 3. I get y equals 2x plus 15. So again, same slope, so I know these are parallel. Different y-intercepts though. So these aren't the same line, these are 2 different points in the graph, which means they're never going to touch. So parallel, and again, don't know what I'm doing with the last L in parallel. That's a P-A-R-A-L-L-E-L. Don't know why I'm doing it with a T. So parallel and 2 separate lines. Maybe I'm getting excited about the 2 and 2, and I don't know. We're just going to ignore that for today. So perfect. So what I want you to do is I want you to keep that in mind. I want you to pause the video, try number 9, resume the video when you're done, and see how well you did. Okay. So we know that because neither of these are in slope-intercept form, I'm going to have to, negative 18, write out both of them. X minus 2y is negative 4. Okay. So I'm going to subtract my x on this one, which gets rid of that right there. And I'm left with a negative 3y is negative x minus 18. And when I divide by a negative 3, I know not only does it change the signs, but that becomes a fraction. So negative negative becomes a positive 1/3. Negative negative becomes a positive 6. So I'm looking for a slope of 1/3 over here. Let's see what we get. So subtract my x, gets rid of that. So I'm left with a negative 2y is negative x minus 4. So when I divide by negative 2, I get y equals, well, negative negative is going to be a positive. That's 1x divided by 2, so 1/2 x. Negative negative is going to be a positive 2. And so what I'm looking at right here is that our slopes are not the same, so these are not parallel. And that's all we can tell for right now. There we go.